And so the front of your notes should match what's on the board. On the right-hand side, you have a whole bunch of words we are going to write in their definitions. So as we move on through this week, we are going to be doing fraction work. However, today is truly making sure all of us have a baseline of A, how do we talk about what we're going to see, and B, can we do integer operations? These are things that we have to know and be able to do. The reason I say this is because on Friday, you can see on the board, it's written, it's circled in bright orange. You are going to have a very quick quiz on Friday for fractions. It is made to be something that is an easy 100 to start in your gradebook. It is not going to be anything crazy. It is made to be an easy quiz grade. So, keeping all this in mind, let's talk about some of the things we're going to see. First, a variable. Now, a variable is, write with me please, a letter or symbol used to represent, I just abbreviate as rep, a value that can change. If you do not have a note sheet in front of you, you need to get one in the back of the room right now, please. And so again, a variable is a letter or symbol used to represent a value that can change. And so oftentimes we see variables, we see x, we'll see y. In Algebra 1, we see a lot of m, right? M stands for slope. We see that a lot. And as you move up and through math, you'll oftentimes see f, g, h. You may see L, depending on what we're looking at, W, right? Thinking about geometry, some lengths and some widths. A for angles. Any letter really works here. The key is that it's a letter or symbol. It's specifically not a number. Because that is what we think of when we hear constant. A constant is true to its namesake. It is a value that does not change. It is a value that does not change. A constant remains constant. And so variable, we think letters. Constant, we think numbers. -8, 21, -47, 102. Those are constants. Whether it be positive or negative, does not matter. Those are constants. And so we use these, variables and constants, to build expressions. Expressions, however, actually have two sort of subcategories. We have numerical expressions, which is how we read that, numerical. And we have algebraic expressions, again, algebraic. And so numerical expressions contain only constants, not our bow, and operations. Only constants and operations. And so again, 3 plus 4. -4 minus 12. 8 times -7. Those are numerical expressions. I have just numbers and just operations. That's it. Algebraic expressions is where we start to involve now our variables. And so algebraic expressions contain variables, constants, and operations. Again, they contain variables, constants, and operations. And so when we go from numerical expression to algebraic expression, again, we build, right? We now include our variable, 3x plus 1, -4x times 12. negative x or negative y divided by 3. As long as we have that operation, a variable, and a constant, that's our algebraic expression. From there, we can continue to build. And so an equation really is actually now more than one expression. And so an equation is going to be a mathematical statement where two expressions are equivalent. Now, equivalent, same thing as equal, and that truly is the giveaway for an equation. All equations will contain that equal sign. And so if we ever see an equal sign, again, that's our giveaway. That is our equation. Once you've got that last definition, just put pencils down so that I can see, please. Take 10 more seconds. I know that we have a few of us still sort of writing or annotating. Take 10 more seconds, finish up. Good. All right. I'm going to pause on notes because now I need us to jump back into our packet. Go to problem set A in your packet, please. 10 seconds, go.